Hello everyone, now we're going to be covering Euler's method. Euler's method is a numerical method of estimating the value of y for some x in a specific differential equation. If you look at this diagram on the left over here, what we're doing with Euler's method is just simply this. Starting from the initial condition, we're going to take the gradient at this point and draw a tangent at this point for a certain length delta x. This small distance of x, delta x, is just what you call the step length. Now when we reach our next point, we're going to take the gradient at this point and draw what this tangent would have looked like for, again, this small distance delta x. And again, we're taking the gradient at this point and we're drawing a line with the same gradient for a length of delta x so that we can reach our final goal. Now if you can see, this actually gives you kind of an estimate of the y value given this specific x value, with just using the gradient dy over dx without actually finding out what the function y is. If you look here to the right, there are two big reasons why Euler's method may be inaccurate. The first one is that the step length is too large. So let's say we have 0 to, let's say 0.75 here. So we're using a step length of 0.25. If we look at this function fx, this function actually increases quite quickly. Then maybe this step length of 0.25 may be a bit too large. We may need a smaller step length of, say, like 0.05 to get a better estimate. Now if you see this red one, I decrease the step length, which helps give us a better estimate of the y value at this x value. Here, we have the second reason, which they really like to ask in IB, and this is because of the concavity of the graph. If you look at this graph of fx, this is actually like a smiley face graph or part of a smiley face graph, and that's why it's concave up. If the graph is concave up like this, for the specified domain, which is between your initial condition and your endpoint which you want to find, we see that the tangent drawn will always give an underestimate. As you can tell, this is an underestimation, and even if we decrease the step length, this will still be an underestimation. Now instead, if we draw a graph that is concave down, we can see that Euler's method actually gives you an overestimation of the true value of y. So how do we actually apply Euler's method mathematically? First of all, for Euler's method, we want to start off with an initial condition. Then we'll utilize this formula, y plus dy over dx times delta x. Again, dy over dx is just your derivative, and delta x is your step length. Let's look at this question. Use Euler's method with a step length 0.25 to estimate the value of y1, means the value of y when x equals to 1, for this differential equation over here, given that y0 equals to 1, and y0 equals to 1 is your initial condition. So let's write our initial condition here. We have when x equals to 0, y equals to 1. Over here, what we're doing is drawing a table so that we can list out the values of x, y, and this thing, y plus dy over dx times delta x. Now what this does is find our next y point given this y value and this x value. So let's utilize this formula. Y plus dy over dx, we just copy dy over dx, times delta x, which is the step length. If we substitute the values of x and y into this, we'll get 1.25. And again, this is your next y value. So our next y value is 1.25. And our next x value, remember, we're just changing this by delta x. So we're adding delta x, which is the step length. So if we add delta x, this becomes 0.25. We can fill in the rest over here. And again, what I'm doing is substituting this value of x and this value of y into the equation over here to find our next value of y. Since it's an intermediate answer, I like to give my answers in 5SF. So I'm going to copy this down. This becomes 1.4219. If I substitute again, I should get 1.5415. And this is your next x value. If I substitute this again, I should get 1.63. And you can see over here, when x equals to 1, y equals to 1.63. So we have found our value of y1, 1.63. Instead of doing this substitution so many times and inputting into your calculator, what you can actually do is use the GDC spreadsheet to help you. Now listen closely, because the Euler's method in the GDC is not so easy to do. Column A is for all the x values, column B is for all the y values, and column C, if you remember your formula, y plus dy over dx times delta x. So here we can key in our first x value, our next x value, then 0.5, 0.75, we know that the step length is 0.25. So we can just key in all the x values just like that. Now for the y values, we know that the first y value is 1. Now the second y value we don't know yet, but we know that this second y value is the same as C1, right? If you look at this column C, row 1. So since this is the same as C1, I'll write equals to C1 here. This is kind of similar to Excel if you've kind of used it before. What I can do is press Control menu and fill. What this will do is, if I drag this down, it will give me C2, C3, and C4. So it's like mimicking this value, this is mimicking this value, this is the same as this value, and this is the same as this value. And that's what we want for Euler's method. So remember again, what I did was I clicked this, just this box, I pressed Control menu and press fill. And what it does is fill in a pattern where there's C1, there's C2, there's C3, and there's C4. Now for this box it gets a little bit more complicated. We want y plus dy over dx times delta x. Okay, I'll key in an equal sign first. Specifically, we want this y value, b1. Y plus dy over dx. And dy over dx in this case is x minus y squared plus 2. So we want x, which is a1 in this case, minus y squared, which is b1 squared. We want this squared, and then we want plus 2. And we're not done yet, we want this to be multiplied by the step length 0.25. Then you can press enter. And you see, we get 1.25, which is right. So again, we want the y value, which is b1, plus dy over dx, which this is the dy over dx formula in terms of what I want to substitute, and then I times 0.25. Now I'm going to do a similar process. I'm going to do Control menu and then fill, and drag down, press enter. And if you look at what this did, if you look at the next one, this says equals to b2, which is this value, plus a2 minus b2 squared, which is this x, minus this y squared, plus 2 times 0.25. So the GDC is automatically doing this table for you. You don't have to substitute in so many times, you just have to write the formula once, press Control menu, and it'll fill everything in for you. And you get over here, when x equals to 1, we're approximating y to be equals to 1.63, and that's our answer. If you don't really understand this part, I suggest you to watch this part again, but if you still don't understand, maybe it's better for you to do the normal calculator method of just substituting values of x and y. Thank you so much for watching this video. I hope you learned more about Euler's method.